Sejahtera to Dr. Aizuddin and everyone. We are from Group 2 and our group will present the experiment 7, that is estimation of heat capacity and entropy generation. Our group member are me, Lee, Asif, Haziq and Zaru.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarul Azam. I will continue the presentation for introduction part. So, the introduction part for this experiment is to estimate the heat capacity of different metals of block, to estimate the entropy generated when metal block drop in the water. For the experiment, we use three different metal blocks in the experiment, which are brown copper block, silver aluminium block, and black iron block. And then we set the volume of water in the beaker as 60 ml and start to record the temperature of water in the beaker after it reach 80 degrees Celsius until a certain temperature, which is when the temperature is in equilibrium. So I will continue the presentation for theory part. The amount of heat lost by the warmer body is equal to the heat obtained by the cooler body when the two bodies exchange heat at different temperatures and some intermediate equilibrium temperature is eventually reached. So there is a few formula here. Formula for heat lost by the solid is equal to mCp times different in temperature for solid. Second formula is for heat gain by water. M M2Cp times different in temperature for water, and this one is information for Cp water. Specific capacity for water is 4.187 kilojoule over kg K. At equilibrium temperature, T2 solid is equal to T2 water. So for the last part for theory, the change in entropy of the system or its environment may be negative, but the production of a total entropy is a positive. For delta entropy, the formula is delta entropy is equal to mCp ln times T2 over T1, and for the total entropy, delta total entropy is equal to delta entropy metal times delta entropy water. That's all from me. I will pass for next presenter.
So, for the experiment setup, we will be using thermometer, beaker, weighing scale, hot plate to heat up the water, aluminium foil to reduce the heat loss of the water, glove, and the material we use is aluminium block, copper block, and iron block, and we choose the smallest one. For the methodology, first we're gonna weight and record the aluminium block weight by using weighing scales. The second part, we're gonna pour 6 ml of water into the first beaker and heat the water by using hot plate. Then the aluminium block is attached with the metal string and place it into the heated water. The aluminium block is ensured to be fully submerged into the water, and the aluminium block is allowed to be immersed in the water until the temperature of the water reaches 90 degrees Celsius. So for the third part, we're gonna pour 60 ml of water into the second beaker while waiting for the aluminium block to heat up. After that, we're gonna measure the initial temperature of the water in the second beaker by using thermometer. For the next part, we're gonna take out the aluminium block from the water after it reaches 90 degrees Celsius by using metal string and transfer it immediately to the second beaker. The second beaker is covered using aluminium foil to minimize the heat loss to the surroundings. And lastly, for the temperature is measured and recorded at every interval of 10 seconds until the temperature reaches equilibrium. The water is stirred throughout the process to ensure the heat is distributed evenly. And lastly, the experiment will be repeated by replacing the aluminium block with copper block and iron block.
Hello, my name is Muhammad Asizrin. I will present about the result and calculation part. For results, that as Doctor can see, the table in the left hand side, that is a result that we get that we've got after the experiment, during the experiment, and the time that we measure in unit second, and we took the initial temperature of water first, and after that, after 10 seconds, we took the temperature of water again until 60 seconds, and then we took the equilibrium temperature during 60 seconds just now lah, and then for each part, and then for table below, that is a calculation data that we did after the experiment based on the results. And for the mass, we measure before we did the experiment, before we hit that kind of metal, and for the specific heat capacity of water, as we all know, the specific heat capacity of water is 4.187 kilojoule over kilogram Kelvin. And for delta T of water, the calculation we did, we do the subtraction between equilibrium temperature based on the results and initial temperature of water. That's how we got the delta T of water for each part. For aluminium 3 Kelvin, copper 3 Kelvin, iron 4 Kelvin. And for the metal, we did the calculation by subtracting 90 degrees Celsius of metal. Each metal is 90 degrees Celsius minus with equilibrium temperature. 90 degrees Celsius, that temperature we during the experiment, before, based on the procedure, we need to heat the metal before we get the result, which is 90 degrees Celsius lah. And for the for the specific for the heat gain by water, we calculate based on the formula as stated in the right hand side, which is MCP delta T. CP means specific heat capacity of water, and we got the result for each aluminium, copper and iron in water. And for entropy change of water, we do the calculation by using the formula MC P ln T2 over T1. M for mass, CP is specific heat capacity of water, ln T2 over T1. T2 equilibrium temperature, and T1 initial temperature of water. T2 T1 needs to be in Kelvin. And then we do the specific heat capacity of metal. We calculate by using the formula heat gain by water over heat loss by metal. Here we've got the specific heat capacity of what for metal, and then we calculate the metal part of we calculate the entropy loss and change of entropy of metal, and then we calculate the entropy generation, the total, which is metal entropy for metal plus water, and then we've got the results. For the mass of water, is 0.06 kilogram, which is equivalent to the volume that we use, which is 60 milliliter. 1000 milliliter is equals to 1 kilogram. Alright, next, this is the graph that we plotted based on the results and calculation that we did previously, and as Dr. can see, the graph is according to the specific capacity of metal that we calculate just now. And as Dr. can see, the graph, copper has the lowest specific heat capacity of metal compared to iron and aluminium, and aluminium has the highest one. Is the highest one. This means that copper is thermal conductivity of copper is better than aluminium and iron, because the specific capacity of copper is the lowest. It is because based on the definition itself of specific capacity. Specific capacity is quantity of heat required to increase the temperature by 1 degree. And I think that's all from me. Thank you.
Procedure of this experiment are: wear a lab coat throughout the experiment. Second one is wear heat resistant gloves to avoid scald. Next is the discussion of this experiment. Firstly, we need to determine the source of error and method to minimize the error. Parallax error occurs when observer reads the temperature scale of the thermometer. Environmental error may be occur when the windy condition in the lab and not cover beaker. Lastly is instrumental error, as the thermometer contact to the beaker's wall. Way to minimize error. Observers should put their eyes perpendicular to the measurement scale of the thermometer when taking the reading. Ensure the experiment is carried out in closed environment. Cover the beaker with aluminum foil to minimize heat transfer to surroundings. Avoid the thermometer contact with beaker during the experiment. Next, we need to stir the water in the container after metal is transferred into it to ensure the heat distributes faster and evenly. It can increase the rate of heat transfer and make the temperature reading more accurate. We also need to transfer the metal quickly into the container to prevent heat losses to the surrounding. As longer time metal block exposure to the air, the more heat losses to the surrounding, and finally affect the accuracy of the results. Lastly is the conclusion of this experiment. Different materials will absorb heat with different rate due to their specific heat capacity. Aluminium have the highest experimental value of heat capacity, that is 0.906 kJ per kg Kelvin, followed by the iron metal 0.4299, and the lowest specific heat capacity metal is copper, that is 0.337. Total entropy generated for aluminium, copper and iron is 0.00058252 kJ per Kelvin, 0.0005825 kJ per Kelvin, and 0.000784 kJ per Kelvin respectively. Total entropy generated for copper metal is highest compared with the aluminium and iron. The experimental value may be different to the theoretical value because of some errors occurred affecting the accuracy of the results.